today I am going to explain about the solid principle. That is the very important topic in the C# programming language, and in each and every interview, we are it was asked by the interviewer. Okay, so I will bit explain in the code also, but first just I want to show you what is the solid means. There are five rules for the good coding practices we need to in your coding practices. Okay, the first rule is the S means single responsibility principle. Second one is the open close principle. Third one is Liskov substitute principle, and fourth one is interface segregation principle. D means dependency inversion principle. Okay, so everyone has a mind. What are the benefits of solid principle? The first benefits, it makes software design more flexible, maintainable, loosely coupled, testability. That is the very good like the benefits. These are the very important benefits in every like the coding practices we are doing day to day coding. So we have to implement in my our coding practices. We have to use the solid principle. Let's go one by one. First is the single responsibility. Single responsibility means each and every class should have a single responsibility. Let's see by an example. This is the one class. You can see here. I have a class user which have the two methods, print user info, and also I am storing the data in database. So there are two things I am doing in this class. The- As per Solid's principle, this is not a good design. Okay. So what should we do? We have to keep a class user differently, user related, and we have to create a class user printer where we will add the method print user info. Okay, and we will create the different class user data store and add the method store user data. In this way, we created the three different classes, and each class has the single responsibility. Printer class, this class has the responsibility to print. This class has responsibility to use they store the data. Okay, this is the first principle of the solid principle, that is the very important while designing the class. Okay, now let's second principle, open close principle. Open close principle means, let me explain bit more and then we'll show the how to design in the code. Open close principle means open for extension, means we need to create a database class, base class, and that class available for extension. And close for modification means we have changing the base class every time in the suppose any new requirement comes, then we are changing the class every time. Let's see understood by this example, very simple things. Suppose we have a class rectangle, and this is the two property width and height, and I am calculating the area. Okay, suppose our requirements come, we have to implement the circle class. So what we will do, we will do go to public class circle, and we will create the one radius here. And what we will do there, we will again write a if condition, calculate, we will add one more method here, calculate circle area, and this is the circle, and what is the radius, and here we will calculate okay. So what we are doing, whenever a new requirements come, we are changing our base class every time. Okay, so this is the not a good design of the class. So what we will do now, let's see. So first of all, we introduce a interface shape. Okay, in this interface we created a method calculate area. Now let's see guys, here a class rectangle, and it will inherit the shape, and here is the method calculate area returning width into height. Suppose new requirements come for the circle, then we will create the similar things. We will create the circle. Okay, this is the constructor. If you don't want, then don't use it. We will create the class circle, and we will implement the calculate area, the this interface. Okay, now you can see guys, in our area calculator we are here shape dot calculate area. Every time if new requirements come, we are not changing our concrete class base class here area calculator class. We are just introducing a new class and in implement the shape interface. Means we are extending every time our class. We are not modifying in the our base class, and okay. So that is the second things of the open for extension and close for modification. If you guys any questions, then please add in the comment, I will reply. Now let's see our third principle is the Liskov substitution principle. What is the Liskov substitution principle say? You can see here. Liskov principle said like what said, object of parent class should be replaceable with the object of the derived class without breaking the system. Let's see by example of this how we can implement. Suppose this one, this is the class bird, and there is the one method fly, and here we are writing some implementation. Okay, I am creating a class crow, and that inherited the bird. Bird is our parent class and crew is the our derived class, and we are overriding the fly method and do some implementation. Here in the fusion class we are doing the same things. In this class we don't want the fly method, but we want the some get details method. But as per structure we have to every time implement the fly also. This is the violating of the Liskov principle, because when you run the call the our base class object and this one, it will not work, because we have to implement the fly method also in the penguin class. So what should we do? You can see here we will now introduce an interface I flyable. You can see here fly, and I details, you can see here the get details. Now in each class bird, crow, pigeons, you will inherit the interface. Okay, and implement the fly method. And here we are not inheriting the if level, we are inheriting the I details, and we are getting the get details. In this way, this will not create any issue. At any time you can use the derived class or and base class. There are no such issue occurs. So that is the Liskov substitution principle follow. Okay, let's see the next. Our next rule is interface segregation. That is very much easy. Interface segregation is told that every interface should have this unique type of work. Okay, suppose there is the interface I worker, and we are implementing two method, work and eat. Okay, and here there is the class robot, we are implementing both method. That is fine. Suppose there is another class robot 2. I don't want the eat method. You can see here it will create a issue because we are inheriting the I worker, and we have to implement at per interface policy, we have to implement both method, either it is required or not. That is violating the interface segregation principle. Even we does not want the eat method, but we have to implement. So this type of design of the class is not good. What should we do? Let's see. We have to create the two different interface. You can see for this method I created the I workable. For each method I created the interface I eatable. Okay. What I did, I segregate the both method in a different interface. Now let's see, this method want to implement only this, so we just inherit this interface. For this one I want only eat method, then we will inherit only I table interface, and this one require both method, then I can inherit both interface. Okay, the based on the requirement we can inherit the different interface. That is the good way of implementing the solid principle of interface segregation. That is very important for us. That is the fourth law of the interface segregation. Now our next is dependency inversion. What dependency inversion said? High level modules does not dependent on low level modules. Means, let's see the example. Here is the class email service, and under this class we have a method send. Now there is the another class notification, and I am creating the object of this class, and this under this method I am sending the mail. So what's you can see here, notification class is dependent on email service class. Whenever anyone try to create the object of notification and want to call notify method, then definitely you can see if any issue in this email service, then it will not work. And that is both classes are very much dependent to each other. So that is not a good design for the programming practice. So what should we do? We make the loosely couple. Loosely couple means both classes should not dependent to each other. We are decoupling. Okay. How we should do this? That's you can see here. I created interface, I message service and method send. You can see here send method under this class, but I introduce an interface. Now there are two class, email service and notification. I created an email service which inherit the interface, and implementing the send method. Okay. In the notification class, I am not directly creating the object of email service. Instead of I injecting the interface, you can see here I message service, and I am injecting that interface in the constructor of notification class in this way, and that object dot send, it will hit the email service. In this way, this is not dependent or directly dependent on email service. Okay. And that is called the dependency inversion. And this way of calling the send method is dependency injection. We are injecting through the constructor here. That is the very important things in the current programming, like the we are not creating the object of the class, we are just through the interface we are injecting that class, and that object we will use to call the method. That is the our dependency inversion principles. Okay. So this is the solid principle and five solid principle, and that is the very important in our programming structure. Hope you guys are able to like the understood about this five concept, and these five concepts is very important. And in every interview whenever you will go, everyone asks what is the solid principle, explain with the example. So hope I am able to provide some details on this. Thank you all. Yeah, thank you for watching the video, and if you have any question, then give me the comment, I will reply as soon as possible. And if you like my video, then please like and subscribe. Thank you.